So we discuss the weekly homework related to topic force, acceleration, and extension. In the first question, a truck accelerates uniformly along a straight horizontal road. The mass of the truck is 2 exponent 4 kilogram. The speed of the truck increases from rest. So originally it was at rest and then it moved to the speed, reached the speed 12 meter per second in 30 seconds. The total distance traveled by the truck during this time, so we need the distance. So distance is average speed multiplied by the time. So we need the total distance. What about the average speed? What is the average speed of 0 and 12? So to get the average speed, we will add, so 0 plus 12 divided by 2. So average speed will come out as 6 meter per second. So average speed is 6 multiplied by time interval, that's given 30. So 6 multiplied by 30, that's equal to 180 meters. The next part, because as you can see in the question, they mentioned the distance is average speed. How you take average of the number? Like example, if I say I have 2 and I have 5, I want to take average of these numbers. So how to take an average? Average is equals to sum divided by the total number. So what is the sum here? The sum will be 2 plus 5 and the total numbers are 2. So 2 plus 5, that is 7 divided by 2. So average will be 3.5. That is acceleration, Abdullah. That acceleration is v minus u over t. They're not asking for acceleration in this part. They're saying we want to calculate a distance and distance is equals to average speed multiplied by time. So how to take average? How to take average of the two number? If one of the number is 0, another one is 12. So how I take average of the number? So 0 plus 12 divided by 2. So average will be 6. If there were three speeds, like if one of the speed was 0 meter per second, then it was 3 meter per second and 12 meter per second. And I want to take an average. In that case, how I take an average? I will add them and divide by 3. So because the sum divided by the total number, that is how we take an average. So distance is average speed multiplied by time. It was starting from rest, so starting speed is 0 and the final speed is 12. So how to take an average speed? So one of the speed is 0, another one is 12 and then divided by 2. That's why the average, this is not the acceleration, this is the average speed, which is 6 multiplied by time interval 30. So we get the distance, which is 180 meters. Now the next part, we need the resultant force. So the formula which we use for resultant force, F is equals to ma. We have the mass, that is 2 exponent 4, but we don't know the acceleration. So we have to find first acceleration. And how we can find the acceleration? If initial acceleration is final velocity minus initial divided by time. So final velocity is 12, initial is 0, divided by time interval, that's 30. So it will be 12 minus 0 divided by 30, that's equal to 0.4. So the acceleration is 0.4. We need the resultant force. So F is equals to ma. Mass is 2 exponent 4 or 20,000 multiplied by acceleration is 0.4. So 20,000 multiplied by 0.4 will get the resultant force as 8,000 newtons. In the next part, to maintain a uniform acceleration, the forward force on the truck must change. To have a uniform acceleration or constant acceleration, the term uniform means constant. So to have a uniform acceleration or constant acceleration, there must be a constant resultant force. So to keep the constant resultant force, the forward force on the truck must change. We should increase the forward force. What is the reason? Because what happened when the truck speed is increasing, the air resistance, like example, if we need a constant resultant force of 100 newtons, because we need a constant acceleration, so all the cases we need the resultant force to be constant or should not change. So what happened as this object is accelerating, it means the speed is increasing. So here example, it was moving with 5 meter per second, then it is moving with 10 meter per second, then it is moving with 15 meter per second. So as the speed is increasing, speed is changing. So what happened? The air resistance, the force which is opposing the motion, that is also increasing. If the air resistance example here is 50 Newton, but because it is moving at a higher speed now, the next position, so air resistance will be higher, maybe 100 Newton. And as it is further increasing the speed, so air resistance further increases the force which is opposing the motion. Now it is 150 Newton. So we want the resultant force, we want the resultant force to be 100 every time, or we need a constant acceleration or constant resultant force. So the driving force, the force which is moving this object, that must also increase. So if we want a resultant force of 100, how much should be the driving force? So driving force should be 150, because 150 minus 50, result will be 100. Here the friction force or air resistance is 100. So how much should be the driving force? The driving force should be 200 Newton. And here the friction force is 150. So how much should be the driving force? That's equal to 250 Newton. So as you can see, how you'll write this answer, because you don't have to explain, you just have to write the answer. So you'll mention, as the object is accelerating, its speed is increasing, which increase the air resistance, or you can say drag. So when the object is accelerating, its speed increase, and whenever there's speed increase, the air resistance, the force which opposes the motion, will also increase. And that what happen, then the driving force should increase to maintain or to create a constant resultant force for constant acceleration or uniform acceleration. So these are the points you have to include. Number one, speed is increasing, so air resistance increase, that is 1 mark. And when the air resistance increase, you have to increase the driving force so that there will be a constant resultant force on the object. In question 2, in a crash test, the passenger compartment moving with a velocity of 20 meter per second comes to rest. So this is the starting speed and the final speed is 0, because it comes to rest or stops, and the time is 0.2 second. Calculate the deceleration. Acceleration and deceleration have the same formula, but final answer for deceleration will come out as negative. So acceleration or deceleration is change in velocity v minus u over t. So final velocity is 0, initial velocity is 20, and the time interval is 0.2. So it will be minus 20 divided by 0.2, which is equals to 100, negative 100 meter per second square. So negative sign only shows it is decelerating, but we need the number here. That's why we are writing 100 meter per second square. The significance of a negative sign of acceleration means that the object speed is decreasing or object is slowing down. The second part, the seat belt and airbag bring the dummy to rest so that it does not hit the windscreen, the front screen of the car. The dummy has an average deceleration of 80. Calculate the average resultant force when the mass of the dummy is 70. So resultant force, average, total, all have the same formula. F is equals to ma. So force is mass multiplied by acceleration. Mass is 70 and acceleration is 80. So 70 multiplied by 80. 7 multiplied by 8 is 56 and then two zeros. So 5600 Newton. State why the force is a vector quantity. Why a quantity can be a vector? Because it is having a direction. So whenever quantity is having a direction, it will always be a vector quantity. A force of 50 Newton and force of 20 Newton and 15 Newton act at the same time on the object of mass 14 kilogram. The maximum possible resultant. So what will be the maximum possible resultant if two forces are acting in the same direction, like a 20 Newton and 15 Newton? If both act in the same direction, we'll have a maximum possible resultant. So the resultant, because they are in the same direction, so we will add the two forces to get the result. So 20 plus 15, that's equal to 35 Newton. Then calculate the acceleration caused by the resultant force. So we have to calculate acceleration caused by this resultant force. Have the formula F is equals to ma. So force is 35, mass is 14, and acceleration we don't know. So 35 divided by 14, that's equal to 2.5. So 35 by 14, acceleration will be equal to 2.5 meter per second square. If the same question was there and they mention calculate the minimum instead of maximum, it was a minimum. So what is the minimum resultant? When two forces are acting in opposite direction, in that case it will be a minimum resultant. Like one force is 20, which is towards right, example. The other force is 15, which is towards left. So resultant will be 5. So when two forces are acting in opposite direction, resultant will be small or it will be a minimum value. And when two forces are acting in the same direction, resultant will be maximum. In question 4, a train has a mass of 5.6 exponent 5 kilogram. It is at rest. At time t is equals to 0, the resultant force start to act. So what is happening initially? Because it's a distance time graph, the slope represents speed. So it is accelerating. And here it is constant speed. Use figure 1.1 for the average speed. So average speed is the total distance divided by total time. So for total distance, we'll take the y-axis, which is 4,800, and the total time is 120. So it will be 4,800 divided by 120. So it will be 40 meter per second. Then the speed at 100 second. So we want the exact speed at 100 second. As you can see, this part is a straight line. So speed, it means the speed does not change for this part. Because it's a straight line, slope is constant, so it means speed is constant. So 100 second, we want the speed at 100 second, but actually speed remains same from about 70 second to 120 second, and it is a straight line. So we can find the distance divided by time in this region. So we'll get the speed in this region. This is 4,800. This one is 2,000. So the distance travel with a constant speed, it is from 2,000 to 4,800. So distance travel is 2,800. And how much time it took? So that is 78 till 120. So from 78 to 120, the speed does not change. So that is 42. So to get the speed in this region, because speed in this region is same as speed at 100 second, so it is 2,800 divided by the time interval, which is 48. So 2,800 divided by 42, which is 66.6 meter per second. And describe how the acceleration of a train of train at t is equals to 100 seconds from differ from acceleration t is equals to 20. So how we compare these acceleration? A straight line is still 60. Yeah, Abdullah, you can take any, because in this region it's not necessary that I take for full part. Like as you are mentioning, the straight line is still 60. So even if I draw a shorter line, I can work out the speed in this region, because in this region the speed does not change. I will get the same result. So basic idea is that because it's a straight line, so when it is a straight line, it means the speed does not change for that region. And if speed does not change for the region, we can find for any part. I can take this part, I can take the other part. Only within the line I can take any part. The answer will have a range. So this answer is having a range. It can be from 50 to 60. Any value from 50 to 60 is acceptable. The next part they're saying describe how the acceleration of a train at 100 second compared with 20 second. At 100 second, it was moving at a constant speed. So when something is moving at a constant speed, it means acceleration is 0. But at 20 second, what is happening? It is accelerating because the slope is increasing. So here at 20 second, acceleration is there, but at 100 second, the acceleration is 0. Why acceleration is 0? Because the speed is not changing, and when the speed does not change, the acceleration is 0. The initial acceleration of a train is 0.75. We need the resultant force. So F is equals to ma. 0.75 the acceleration. What about the mass of the train? That is given in the beginning of the question. That is 5.6 exponent 5. So mass of the train is given 5.6 into 10 to the power 5. You multiply them. So you will get 4.2 into 10 to the power 5 Newton. You can write your answer in significant scientific notation, that is appropriate, but you can write as a whole, but better use the scientific notation for to represent the final answer if it is too big. Instead of writing 4200, just you can write in scientific form. At t is equals to 120, train began to decelerate. What is the meaning of deceleration? The term deceleration means speed will decrease. So when the speed decreases, we use the term deceleration. Then question 5 state Hooke's law. According to Hooke's law, that within limit of proportionality, force and extension are directly proportional. This is a mathematical notation I mentioned here, but when you write in exam, you will mention force or extension proportional to the applied force. Figure 1.1 shows a graph for stretching force and extension. State the feature of the graph that shows it is obeying a Hooke's law. So whenever a spring or an object obey a Hooke's law, how we can say that it is obeying a Hooke's law? Number one, it should be a straight line, and number two, it should start from origin. So because this is a straight line and it is starting from origin, so this shows that force and extension are directly proportional, or it is obeying a Hooke's law. So when two quantities are directly proportional, there will always be a straight line starting from origin. Then the next part, we need the value of the k. How to get the value of the k? So within the straight part, you can find the value of the force. Each box is representing 5, so it is 105, 10, 15, 20, 125, and 50. So 125 divided by 50, that will give us the value of k, because k is force divided by extension. So this will come out as 2.5. Unit of force is Newton and unit of extension was millimeter. So it is Newton per millimeter. If it was in centimeter, then Newton per centimeter. If it was in meter, the extension, then Newton per meter. Then the limit of proportionality of a spring is reached at 50 millimeter. So now it does not obey the Hooke's law. Suggest how the... So basically what happened, we are increasing the force. Now it is not obeying a Hooke's law. So if it does not obey a Hooke's law, then it will not be a straight line. It will start to be a curve. And there is another spring which has a smaller value of a k and it obey a Hooke's law till 80 millimeter. So if it obey a Hooke's law till 80 millimeter, so it means there should be a straight line. And if because force is small, it is having a smaller value of a k, so it means it needs a smaller force to produce the extension. That's why it will be below the original line. If they say it was having a higher value of a k, then it should be above the original line. And why it is a straight line? Because they mentioned it is obeying the Hooke's law till 80 millimeter. Is it clear? This was a weekly homework related to topic force, acceleration and extension. Any question? Any question or a doubt?